Hello, Heritage Academy geometry students, and welcome to another riveting geometry lesson brought to you by Mrs. Elzagari, PowerPoint, and of course, the internet. This is lesson 2.4, that is chapter 2, lesson 4. You are going to want to refer to your textbook, and don't forget to have your Cornell notes out. Get that pencil ready for writing. Let's get going. Throughout chapter 2, we've been exercising our brains in logic. We've done some deductive reasoning. We've worked on conditional statements, biconditional statements, converses, inverses, contrapositives, and even syllogisms. In our last lesson, we sort of started to get an introduction to this idea of going from a syllogism into a direct proof and a theorem. So we're going to continue to build on these concepts today, only this time we're going to look at some indirect ways to reason using logic. And before we go any further, let's review our ultimate objectives for chapter 2. We know that our God is filled with logic and order. He shows this in the Bible. He shows it in the entire world around us. And because His logical plan for us is good and perfect, then He expects us to learn about, practice, and use this incredible gift of deductive reasoning that we have for His purposes. Now, more specifically for lesson 4, our intermediate objectives are to explore indirect reasoning today and determine possible conclusions from indirect reasoning. We're going to learn how to use assumptions and contradictions to determine what we would call an indirect proof. And finally, we're going to develop a sequence of conditional statements to write short proofs for theorems. Once again, this is lesson 2.4, indirect proof. Get that textbook open to page 55. Get your pencil ready. Get your Cornell notes in front of you. Let's do this. So recall from our previous lesson, we learned that we can connect different conditional statements together in a syllogism. And a syllogism is an argument of the form if A then B, if B then C, therefore if A then C. Now this lesson starts off with Anno's hat tricks, and I'll let you read some of the introductory material yourself. But if we take a look at this last paragraph, it says Anno's hat tricks begins with a hatter who has a lot of hats in his box. In the first trick, he takes one red hat and one white hat and puts one on you and one on a friend named Tom while your eyes are closed. Ooh, what is going to happen? Now I know you're on the edge of your seat, so let's continue. When you open your eyes, you see a red hat on Tom. So what color is your hat? We can put the word if to work, and you can reason that if Tom's hat is red, then mine must be white. Makes sense, right? Well, in the second hat trick, the hatter starts with 3 hats, 2 red and 1 white. He puts one on you and one on Tom while your eyes are closed. When you open your eyes, you again see a red hat on Tom, and when Tom looks at your hat, he knows that his hat is red. So what color is your hat? Well, this time we can start by assuming that your hat is red. If your hat is red, then Tom wouldn't know whether his hat is red or white because there are 2 red hats. This contradicts the fact that Tom is sure his hat is red. Therefore, the assumption that your hat is red is wrong and your hat must be white. So we arrived at this conclusion by reasoning indirectly. Feeling a little confused? That's okay. Go back to page 56 and read through some of these examples again, and they will start to make more sense. But for now, let's talk more about indirect proof. So we need to make an assumption about a conclusion when we're working with indirect proofs, and then we're going to reason until we find a contradiction. Once we find that contradiction, we're going to state the desired conclusion. So essentially, an indirect proof is an assumption made at the beginning that will lead to a contradiction. The contradiction indicates that the assumption is false and the desired conclusion is true. So again, the hatter is going to start with 3 hats, 2 red and 1 white. Again, he puts one on you and one on Tom, and when you open your eyes, you see a red hat on Tom again, but this time he doesn't know what color his hat is. So what color is your hat? It must be red, but do you see why? So we can suppose that your hat is not red. If your hat is not red, then it has to be white. If your hat is white, then Tom would know that his hat is red, just like in the previous example. So this contradicts the fact that he doesn't know what color his hat is. Therefore, what we supposed is false, and your hat must be red. So let's look at a pattern of two short proofs of some theorem, if A, then D. Let's do direct proof first because we're pretty familiar with this. So if A, then B, if B, then C, if C, then D, therefore, if A, then D. But how does this apply to an indirect proof? Well, we're going to suppose the conclusion is not D, and we're going to say that not D is true. If not D, then E. If E, then F, and we're going to continue until we come to some kind of contradiction. Then we can say, therefore, not D is false, and so D is true. So how does indirect proof actually work? Well, let's explore this with a real simple example. So pretend that you're holding this hand of cards while you're playing a game of 5-card rummy. So we can have a theorem in which we state, in this deal of the cards, no one holds a royal flush. Our conclusion would be that no one can hold a royal flush because, of course, to have a royal flush, you would have to have a 10, jack, queen, king, and ace of one suit, and that's not possible if you're holding all 4 tens. So step one is we need to assume the conclusion is not true when we're trying to write an indirect proof. Step two, we're going to reason logically using a conditional statement or a series of conditional statements, which of course is deductive reasoning using our if-then statements. And we're going to do this until we find a contradiction of known fact. And finally, after we find the contradiction, we're going to point out that the assumption must be false and the conclusion must be true. So if our conclusion says no one holds a royal flush, then a way to assume the conclusion is not true is to say, suppose someone holds a royal flush. Now, when we move on to thinking logically about this with conditional statements, we'll say, if you hold all of the 10 cards, then no one can have a 10 card. And if no one can have a 10 card, then no one can have a royal flush. That right there shows us our contradiction. So then we go back and say that the assumption that someone holds a royal flush is false, and no one holds a royal flush. Now, when we were going through the steps of writing an indirect proof, did you go and write those in your Cornell notes? If not, hit rewind, get it done. Now, if you're feeling a little bit overwhelmed about indirect proofs, no need to fear. Llama Corn is here, and he believes in you because you've got this. We're going to go through sets 1 and 2 in class the next time we meet so that we can all continue learning together. Until then, have a great day, class.